All right, so let's go big. All right, let's combine simplifying radicals with constants and with variables. All right, we can still use previous properties, the multiplication property, in which we can split this. All right, this is my suggestion. I know it says root 54 n to the seventh, but we can just simplify this to root 54 and then root n to the seventh. We can do this as two completely different problems. So let's just first do the root 54. All right. Remember, we want to find the largest perfect square that goes into 54. All right. So we can go through our list. We can start with 4. If that doesn't work, we can go to 9. Oh, yeah, 9 goes in there 6 times. We can keep going. 16 doesn't work. 36. So it's just going to be root 9 and root 6. 9 times 6 gives me 54. Root 9 times root 6 will give me root 54. Same exact facts. So now I can do root 9, which is 3. The square of 9 is 3. Root 6 is root 6. Now I want to double check. Does root 6 have any perfect square factors? No, it doesn't. So now root 54, this part, becomes 3 root 6. Now I want to go to the second part, the variable. All right. N to the seventh, root n to the seventh power. If you recall, if the exponent is even, we simply cut it in half and that's the square root, but it's not, it's odd. So what I want to do is I want to find the largest perfect square factor that goes into this. The largest perfect square factor is always, 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 always 1 less than the exponent. So if it's n to the seventh, the largest perfect square factor is going to be n to the sixth. And I also am going to be left over with one more n. You're always going to be left with 1. Now I can break this down into n to the sixth times root n. The square root of n to the sixth, we take half of that, which gives me n to the third. The square root of a variable to an exponent is always going to be half of that. Root n is going to be root n. All right. So now I have 3 root 6. This is all multiplying times n to the third root n. This brings us to something new. Anything out in front, we can just multiply together. This is all multiplication. All right. 3 times root 6 times n to the third times root n. So I can rearrange this all I want. I'm going to take this 3 and this n to the third and put them out in front. And now I can reverse my thinking. You know how we broke this apart into root 54 and root n to the seventh because they're multiplying together? I have root 6 and root n. They're broken apart. I can now take these two and put them back together under the radical. So root 54 n to the seventh, after we break down each piece, we go down, simplifies down to 3n cubed root 6n.